Hey guys, Mr. Betts here. I want to take a look at an example that you actually wouldn't have to do for me on an assessment or on the AP test, but it is an example where L'Hopital's rule can apply using an indeterminate form, but in a little bit of a different way. So first of all, let's look at what happens here with this particular example. As x gets really big, then 1 over x, 1 over infinity is going to be really small. It's going to approach 0. So the inside of this is going to approach 1. And then this, obviously, that x is getting really big, it's going to approach 0. So we have some conflicting rules here. 1 to any power is generally 1. However, we have to think of this number here as not being 1, but a number really close to 1. And if we take a number, any number bigger than 1, and raise it to an infinite power, it's going to get really, really big. So we've got one rule saying 1 to any power is 1. We've got another rule that's saying anything to an infinite power is going to be really big, at least a number bigger than 1. And those two might balance each other out. So it turns out that 1 to the infinity is an indeterminate form, just like 0 over 0 is an indeterminate form. So the way we're going to handle this is we're going to do a little trick that uses logarithms. So if we think of this as y, so we say y equals 1 plus 1 over x to the x power, and we take that equation, we take the natural log of both sides. So we get the natural log of y equals the natural log of 1 plus 1 over x to the x power. By using a logarithm, then this exponent here we can take out front. So the x can go out front and rewrite it as this. So what I'm going to do here is I'm going to take the limit of this expression, and then remember that what we're really finding is the limit of the natural log of this expression. And then after we do that, we can take into account that it's the natural log and go from there. So I'm going to look at the limit as x approaches infinity of x times the natural log of 1 plus 1 over x. Now, this one is going to end up being infinity times the natural log of 0. Nope, sorry, natural log of 1. And the natural log of 1 is 0. And infinity times 0 is another one of these indeterminate forms that face value doesn't necessarily look like 0 over 0 or infinity over infinity, but it is, in fact, one of those two. So I'm going to do a little trick here with the x, and instead of having it as x, I'm going to have it in the denominator as 1 over x. So we're looking at the limit of the natural log of 1 plus 1 over x over 1 over x. And by doing that, now we finally have an indeterminate form that we're familiar with, because the limit as x approaches infinity of the natural log of 1 plus 1 over x. So the 1 over x, remember, is going to 0. So 1 plus 1 over x is going to 1, and the natural log of 1 is 0. And then in the denominator, as x gets really big, 1 over x is going to 0. So in this form now, we can use L'Hopital's rule. So applying that, we still have x approaching infinity. The derivative of our numerator here is going to be, remember, derivative of natural log is 1 over this expression, but then we have to multiply by the derivative of that. Think of the 1 over x as x to the negative 1. So the derivative is going to be negative x to the negative 2. So it's going to be negative 1 over x squared that we multiply by. On the bottom, we have that 1 over x. So we have the negative 1 over x squared there. And just doing a little simplifying, these are going to cancel each other out, and we get a 1 there. Plug infinity in for x. Remember, we can't actually plug infinity in, but we can see what happens when x gets really big. This term's going to approach 0, and we get 1. So what we need to keep in mind, though, is that this expression right here is approaching 1. That's the natural log of y. So if the natural log of y is approaching 1, So I'm just going to say for the argument of this problem, natural log of y is approaching 1. I'll use the arrow. If the natural log of y is equal to 1, then y is going to equal e to the 1. So what that means is this is going to be essentially e to the derivative, or I'm sorry, not derivative, the limit that I got there, e to the first power, or just e. Again, this is not a process that you would have to do, but I did want to show you that we can use L'Hopital's rule for some indeterminate forms that are not 0 over 0 or infinity over infinity. We just have to rewrite things and look at pieces of the limit that can be written in that form. I also want to point out that this is a special limit. This limit here is actually how the value of e is defined. So there is a small problem with this process because the way e is defined uses this limit right here. And then in order to solve the problem, we use the natural log, which uses e, which is defined by this expression to begin with. So there is a sort of circular reasoning here, but it does turn out that because we use this to define e, we should be getting e for our answer.